Bon, ok, bah, je crois qu'on va commencer quand même, il est 10h15. Ok, alors bonjour tout le monde. Je vous remercie pour votre présence aujourd'hui, même si elle n'est pas réellement physique. Alors tout d'abord, je profite de cette opportunité pour vous souhaiter un joyeux fête et Mubarak. Et j'espère que tout le monde se porte bien durant cette période qui est quand même assez difficile. Alors aujourd'hui, sans trop tarder, nous avons la chance de se réunir grâce à l'application Zoom pour une présentation qui concerne principalement la géologie de la région du Borborema, qui se situe dans la partie nord-est du Brésil, ainsi que ses connexions probables avec la partie nord-ouest de l'Afrique. Alors, brièvement, il est à noter qu'autour de 600 millions d'années, globalement, ou pendant le tout néoprotérozoïque, le supercontinent Gondwana a été formé par plusieurs continents que l'on connaît géographiquement aujourd'hui, notamment le continent sud-américain et africain. Alors, en effet, ces deux parties sont connues par leur mutuelle évolution géodynamique. Et donc, aujourd'hui, nous avons la chance d'apprendre ce qui s'est passé réellement dans la partie sud-américaine et quelles sont les connexions probables avec la partie africaine. Alors, Fabricio, aujourd'hui, va nous synthétiser un petit peu ces récents travaux qui parlent grosso modo de tout ça. Alors, pour ceux qui ne connaissent pas Fabricio de Andrade Caxito, j'espère que je l'ai bien prononcé, Fabricio, ou du moins ceux qui ne l'ont pas croisé lors de son séjour à Alger. C'est un professeur en géologie qui est actuellement à l'université de l'UFMG à Belo Horizonte au Brésil et qui travaille principalement sur l'évolution géodynamique des terrains précambriens ainsi que leur évolution au cours des temps géologiques. Alors, il a effectué un séjour scientifique en 2019, si ma mémoire est bonne, et il a donné plusieurs conférences à l'université de l'USTHB ainsi qu'au craag, et il collabore actuellement avec plusieurs doctorants, docteurs et aussi professeurs algériens sur la partie bulgarienne. Alors, comme vous le voyez dans ce slide-là, cette collaboration a déjà fait naissance à un très joli papier scientifique concernant les similitudes entre la partie nord-est brésilienne et aussi nord-ouest africaine. Alors, sans trop tarder, je voudrais juste vous informer, ou bien beaucoup plus les personnes qui n'ont pas l'habitude de poser des questions, d'utiliser Zoom. Ce serait bien si jamais vous voudriez bien poser des questions et tout ça, d'appuyer sur le bouton réaction. Ça dépendra de votre version linguistique de l'application Zoom. Et ensuite, vous avez soit levé la main en français ou bien en anglais. Comme ça, on va s'assurer de ne plus louper des questions. Alors, je crois que je vais céder la parole à Fabricio pour qu'il commence sa présentation. OK. Fabricio?
OK. Bonjour tout le monde. Okay, now it will work. So as I was saying, I'm on a field trip right now. So I just hope the internet connection goes well. And I'll try to do this in English, but you can ask questions, whichever language, like French or English. So now I have to share my screen, right, Bob? I guess I have to wait for you, yeah.
Yeah, I guess that you can share your screen.
Stop sharing first. You can, no.
Now you can try?
Okay.
Yeah.
Yeah, it works.
So if I just hit it here, is it working now?
Yeah,
Everybody can see it? Okay, so I'll just go ahead with it. and then we can discuss later. This is a figure by Cordani et al. I don't really like everything in this figure because I don't know if there's really like distinct blocks like this in Gondwana, or they're just made off of smaller blocks. But we can use it for a distinction between these longitudinal origins, like the West Gondwana here, it's the closer of the Goiás-Farusian Ocean, and the East African origin. Those are the major north-south origins of Gondwana. And then there is a major discussion on our side, the West Gondwana origins, if they mainly represent intercontinental reworking of older blocks, like Archean Paleoproterozoic blocks. And this was mainly discussed up to the 90s, where we didn't have a good geological mapping and geochemical work, geochronological, isotopic work. And in East Gondwana, we had the same discussion, but as geological mapping ensued, we could recognize everything we need for Phanerozoic style plate tectonics. And this comes from a lot of different authors. But in the last years, we had once again a revival of intercontinental hypothesis that is being discussed right now. So how to solve this problem, how to choose between intercontinental and plate tectonics models? We have to try to recognize specific tectonic features like ophiolites, which represent the sites of ancient oceans, ultra high pressure rocks like eclogites and brooches, etc. Magmatic arcs, this is more elusive, but you can try to do it with distinct rock assemblies like expanded calc-alkaline suites and stuff in this kind of sense, and isotope work as well. And the sedimentary record as well, like passive margin sequence. They're often superseded by synorogenic deposits that come from the erosion of the magmatic arcs and the orogenic building itself. And if we have reliable paleomagnetic data, this is not so easy for the geological past, but we can try to trace the path of different paleocontinents and when they came together. And we are advancing with this a lot in Brazil is geophysical imaging of the crust and lithosphere that can point to clues where ancient subduction zones and juxtaposing of domains of distinct structure and composition, like distinct terrains, can be recognized. Just close this here. Got the sun in my eyes. So this is a map, a schematic figure showing the connections between Brazil and Africa in Gondwana. And from northeastern Brazil to northwestern Africa, we have this continuity of the major cratons like São Francisco, Congo, and São Luís is just a piece of the West African craton. And the orogenic areas that are in pink here. And we have the main passive margin sequences in yellow, and then we have synorogenic deposits in orange, etc. So we have some kind of continuation, especially clear if we use the major shear zones as tie points. So we have the Pernambuco-Adamawa shear zone here. We have this Patos shear zone that might continue in East Nigeria and maybe through Eastern Ogar. And the most famous connection is a Trans-Brasiliano shear zone, which goes through northeastern Brazil to central Brazil, and then might continue in Africa as the Kandi. And then we're not really sure if the 450, this is the most classical interpretation, but this might open here in a fan-like, horse tail-like structure, where you have the main north-south shear zones of the Tuareg Shield. And this is just a closer look between the Borborema. It's just a smaller piece of the Benino-Nigerian Shield and the Tuareg Shield, which make up the Trans-Saharan origin. So now looking at the northeastern Brazil, the Borborema Province, this is usually divided in the different sectors by the main east-west shear zones, which is the Patos shear zone and the Pernambuco shear zone. Both are dextral. Then we have the northern Borborema, the transversal zone in between the two shear zones, and then the southern Borborema. And here is the northern margin of the San Francisco crater. Okay, so what is here in light gray? It's the Paleoproterozoic basement of the Borborema Province. So this basement dominates some of the domains, and it's mainly 2.0, 2.2 billion years. So mainly Triassian. We have some Archean stuff as well. This dark gray here are the Archean remnants, and this can get as old as 3.5 million years. So really old stuff here within the Paleoproterozoic domains. And then in dark gray, we have Neoproterozoic fold belts. So here we have the Sierra fold belt, Seridó. So lots of local names, but all of them are like the Farusian belt or so, dominated by Neoproterozoic metavolcano-sedimentary rocks. Okay. Okay. So the Archean seed nuclei, there's lots of smaller nuclei like spread in the province, but then we have in the northeastern part of the province some of the oldest rocks in South America that can get maybe as old as 3.7. We're going to take a look at that. And then go up to the new Archean. Lots of local names here, but not go into that. And then the main crustal type in the province is the Paleoproterozoic basement, up to 2.0 billion years. This dominates the basement. Then we have some metavolcano-sedimentary rift sequence, mainly in the Oros fold belt, and that goes from 1.8 to 1.5 billion years. Okay. We have this magmatism, sedimentation, volcanism, deformation around 1.0, 0.9 billion years is the Cariri's Valles belt. And this is a very unique feature of the Borborema province. We can't find this anywhere else in Brazil, so very particular. And then the Brasiliano cycle, where we have reef to passive margin sequences and ophiolites and eclogites, so probably a complete plate tectonic cycle here. So these are some of the papers that show the oldest rocks, like the Archean rocks. Up to 2004, those were the oldest crusts in South America. So here in the northeastern part here, and this is interesting because in Nigeria, we got 3.5 billion years old rocks as well. So probably a continuation of the rocks in Nigeria. Okay, so those are like the great gneisses and migmatites closer to Natal here. But then last year, we have these newer papers where metamorphic, ultramafic rocks, serpentinites, really nearby the same place in the extreme northeastern here. And they extracted zircons from there that go as old as 3.7. So probably you have stuff here that's similar to the Ishwa Greenstone Belt stuff we have in Greenland, and probably some of the oldest rocks in the world if they go study it. Okay, so other occurrences that go up to 3.5 here in the central part of the province as well. This is all very new. Okay, so gneisses with zircons as old as 3.5. And this was a student of mine that studied this this portion here. And he got lots of different rocks. I can just sum it up. It goes up to 3.2. So, and it goes reworked at the Paleoproterozoic. All of those Archean remnants, they are very reworked during Triassian orogeny. So this is what you call, I guess, Burnian, Birimian, stuff like that. Some people in Brazil call that Trans-Amazonian. So it's all in this same age range here. Sugarian, so at some parts. Okay, so the Paleoproterozoics, all that's in light gray here. So there's a lot of Paleoproterozoic around. And this is a paper by Sergio Neves in 2014, where he interprets all of those Paleoproterozoic remnants, 2.2, 2.0, as part of composites, island arc terrains, and the continental arc here in the oldest, bordering the Archean remnants, okay? So this makes up the great part of the basement of the province. Over that, we have Mesoproterozoic sequence, mainly this purple sequence here. This is the Oros belt, but you also have some punctual intrusions, anorogenic granite intrusions and volcanosedimentary rocks. And this was dated at 1.75, 1.5. And in this paper here, he just shows everywhere in Brazil where we have this rift, this kind of rift sequences. So we have this in the Espinhaço. That's the place that Bob showed, that this Chapada Diamantina. So really nice rift sequence. So it seems like at 2.0, you got the Archean blocks coming together. So they probably form a paleocontinent. And over this paleocontinent, you got continental rifting. So now you've got sufficient continental board that you can rift it apart and develop nice rift sequences like the East African rift system. So going north-south here, we have a rift system that must go through like 2,000 kilometers or so north-south. Okay, so this is an attempt to break apart a paleocontinent that formed at 2.0. Some people call it continent Atlantica. Some people call it part of Colombia. Okay, so there are different names for that. And then we have the Carriles Velhos belt. Those rocks here in deep blue. So I used to interpret this as a belt because it goes like this for 1,000 kilometers or so. But now we are finding different intrusions at the same age range, also here in the southern part, okay? So this might be a little bit more complicated than once thought. And in this belt, you got mafic, volcanosedimentary, felsic, volcanics, intermediary volcanics. So we got all kind of stuff that's all dated in between 1.0 and 960 million years. And there's a great discussion of what does these rocks mean, if they are related to an orogenic cycle as well, or if they are related to a rifting cycle. And if you go to this paper, which is in the same issue of the Brazilian Journal of Geology, we put there a discussion of those models, okay? So here we discuss the evidence for both orogenic cycle in this in the Tonian and rifting cycle. Okay, so I'm here near to a Algiers gneiss seal that was dated at 1.0. So we probably have both sedimentary and igneous rocks at this age range here. Okay, so in our paper in 2014, we interpret this as a orogenic cycle during the Tonian. So we have both rifting and then closing with continental arc magmatism. But this is like very contentious, and it could be interpreted as well as a rifting event. So we need people to work on that. It's not really well understood or well described. We need students to work with this kind of stuff and to see if it continues in Africa. Like if we have descriptions of this kind of rocks in this age range in Africa as well. Okay, so for the new Proterozoic now, we go to the volcanosedimentary belts, which is in dark gray. All of those areas here, at the middle. And I'll just focus on this fold belt here, which is called Riacho do Pontal. And this fold belt, we can describe what we can find in the other fold belts as well. So I'll use that as an example of what you can find. So it's a salt version map system, as you can see here. It's just thrusting over the craton. And we have an external zone, which is the fold thrust belt, which is in yellow. And we have a central zone. In the middle of the central zone, we got ophiolitic remnants. So this is very important for evolution of the province. Okay, so just do a transect here. As you can see, you got the nappes, and here is cratonic basement, and then you got some clipping that's over the cratonic basement. So when you do a north-south or northwest-southeast transect, what we got here is that we go from a central zone where we got everything is upright, and we have high-grade metamorphic rocks that are deformed in the shear zone with a very well-developed horizontal lineation, vertical foliation, myelonitic, as you would expect. And then you go to a truss fold belt zone where you got sheet folds, SC structures, everything is trussing over the craton. And then when you go to the craton, immediately in the cratonic gneisses, the foliation is vertical. So it's not the same foliation as here. So those are cold trusts. You got a décollement or a detachment structure here where you truss the metavolcano-sedimentary rocks over the Paleoproterozoic cratonic basement, and the basement is not affected by the trusts. So it's really like a detachment here. And then if you go further south, you go over the Barra Bonita clip here, another clipping, where you got horizontal foliation for the Neoproterozoic rocks. Okay, so really nice transect here. So the internal zone, which should be this the zone here in the inner part of the fold belt. You got some important structures here, like the Brejo-Seco complex is this black dot here. And the important here is a meta-ultramafic mafic complex, where we got a nice stratigraphy with rocks dominated by olivine. And then you got troctolites, that's just olivine and plagioclase. And then you got gabbros on top of that. And this was studied by master student, Sila Salgado. And it was dated at 900 million years. So it's younger than the Caridis values, which is 1.0. And it represents probably continental rifting, where you got a plume head that furnishes mafic, ultramafic magma to the continental crust. And it even got some nickel, copper, and PGE mineralization, rift mineralizations as well, okay? So this is interpreted as rift related. So this is the beginning of the Braziliano cycle here, where we got late Tonian, middle Tonian rifting of previous continent, okay? Or Rodinia breakup, if you will. So we got here ultramafic zone, transitional mafic zone, upper mafic zone, and we got all kinds of minerals going in and out here, olivine, chromites, plagioclase, pyroxene, etc. And this date of 900 million years is isochrome obtained with some iron neodymium work here, okay? And he also tracked some of the changes in neodymium, magnesium number, etc. And what's interesting is that the mineralized rift, where we got the nickel copper PG mineralization, is where we got the lower neodymium, epsilon neodymium values, because it seems that to have the rift mineralization, to have sulfides, you gotta have continental contamination, you gotta have crustal contamination. So you have the mafic, ultramafic magma coming, and it's metal rich. And when it interacts with crust, it forms sulfides. So we have rift mineralization exactly where you got lower epsilon neodymium values. It was a nice work by Silas, published in this Journal of South American Net Science with the description of a mineralized zone, etc. So for people that likes economic geology, is a very nice work there with all of the sulfides and stuff. Then over that, we got this Paulistana complex, which is made up of volcano-sedimentary rocks, paragneisses, but also lots of metagabbros and meta-ultramafic schists. And when you do the chemistry of those gabbros, they are really like continental rift basalts. So everything here is marking a rift event. And this was dated in the next slide, I'll show you at 888, 885 million years. So we got here the continuation of the rifting, okay? So we got now here the central zone, which is a ophiolitoid zone. All that's in green here. And this is the Mount Ora complex, where we got metabasalt, green schist, metashark, banded iron formation, some metasedimentary rocks as well, clastics, and minor metamorphic intercalations. Okay, and this we published in 2014. We interpret it as oceanic crust remnants. Okay, so here's a photo of amygdaloidal metabasalt. This is all very deformed and metamorphosed, of course. So we got green schist here, actinolite, plagioclase, etc. This is a nice layer of metashark that's interleaved in metabasaltic rocks. So this is probably exhalative rocks, deep sea exhalative, like black smokers and stuff like that. And some clastics as well, not a lot. And we did a chemistry of this, and it's all very similar to transitional Moore basalts. So really like mid-ocean ridge basalts, okay? And some neodymium work as well with epsilon neodymium of 4.5, so very mental-like. And isochrome here, that's not really good in terms of Samarian neodymium isochrome with very similar rocks, right? The ratios are not that distinct, but it shows that's Neoproterozoic, not Paleoproterozoic or etc. So we really need better dates on that to have a better idea of when it was crystallized, but probably around 800 billion years. So we got a nice follow-up here. We start the continental rifting with intrusion of metamorphic, ultramafic rocks in Brejo Seco. Then we got the Paulistana rift at around 808, and then at around 800, this rift has evolved to a oceanic basin, to a small oceanic basin here, okay? Okay. And what's really nice as well, we had some old gravimetric data in magnetic data, and this is the Bouguer anomaly profile. And we have an inflection point with two distinct blocks, a lower block, which corresponds to the San Francisco Crater, and an upper block, which corresponds to the inner part of the origin. And exactly where we have the inflection point, the suture point, we have the metabasalts, the ophiolitic metabasalts. So I just compared this to other suture zones around the world. And it's very similar to what we got in other fold belts or other origins around the world. Maybe not as pronounced because it's more eroded, okay? So we got an older province and a younger province there. Okay, so for the external zone, how is the thrust fold belt, okay? And what we got here is a South Virgin map system. It's a Casanova group, it's a nice name. And we got at the base, a platformal sequence, which is interpreted as a passive margin sequence derived for the cradle. And then on the top, we got the meta-gray rock, felsic metavolcanics, mica schist, which is really immature, and it with younger detrital zircons, which are Neoproterozoic. So this is interpreted as cinerogenic sedimentator. So this is the passive margin sequence, which is just sandstone like quartzite and marble. So we got some, here is really nicely deformed, but it's platformal carbonates. And then on top of that, we got these immature sediments that are probably derived from the ongoing, on-building, developing origin, okay? So there's a provenance shift here that we can track that with the trital zircon data. Okay, so at the base here, the platformal sequence, we got provenance from the Craton, which we have older Archean Paleoproterozoic, a little bit of 1.7, which is the rift-related zircons. But then on the upper sections, we got important peaks at 900 million years, 1.0, which is the Carriers values related, and 650, which is the Braziliano related. So coming from the erosion of the fold belts, okay? So just have some water here, and I want to highlight some of the other important findings. So in the Riacho do Pontal belt, we got a nice resume of what we got at the other belts as well. But there are some important rocks like this high pressure, ultra high pressure rocks, especially in this part here, bordering the Trans-Brasiliano shear zone. So those are the Forquilha eclogites, Itataia eclogites at this part. And there are some eclogites units here at Floresta and here at Bodocó, this part here. So those are Neoproterozoic. Here we got Neoproterozoic ages as well. This is not so well studied. This might be Paleoproterozoic or Neoproterozoic, okay? So it is this region here, this is the Trans-Brasiliano. And then what you got there is those retrogressed, of course, but eclogite lenses with garnet and a hornblende, a little bit of pyroxene that it's remained. So it's really retrogressed, but studied by Tiziano Santos and others. And in the petrogenetic grid here, it goes up to until we got now in between 15 and 20 kilobars. So probably the retrograded part of the eclogity metamorphism. So in between 17 and 22 K bars and around 750 degrees Celsius. And the age of this is 650, 630 million years, okay? So there's a model by Ganadi de Araújo in 2012 showing a Borborema ocean here with closure between the West African continent and the basement of the Borborema Province. And then you got the eclogites forming in the suture zone, okay? This is an older model. So what is nice here is that those eclogites are close by the Trans-Brasiliano lineament that then goes up to the Candy Fault and to the maybe 415, maybe the Adrar. It depends on the author. So there are probably some connections with the eclogites you have around the western part of the Tuareg Shield as well. So this is being interpreted now that by some authors as tracing the vicinities of a major suture zone between this block and this block here, okay? And what's interesting as well is that in red here, we got what's interpreted as Neoproterozoic magmatic arcs. So here's the Goiás magmatic arc, here's the Santa Quitéria arc, we're gonna talk about that. And here some of the arcs of the Tuareg Shield maybe as well, okay? So this in 2014, Ganadi de Araújo and others interpreted this major shear zone as marking the vicinities of 2,000 kilometers long synchronous deep continental subduction, dating this Forquilha eclogites and eclogites in Togo and Ghana as well. Togo and Mali, sorry. So they have all high pressure, ultra high pressure rocks there. The Brazilian rocks are the lower pressures, and they're all dated at approximately the same time range, like 600, something like that, okay? And this is the Brazilian ones. All of them showing this metamorphic paths going through ultra high pressure rocks and then coming back to the retrograded paths here. And then Cordani and others interpreted the significance of this Trans-Brasiliano Candy 450 or other shear zones in Ogar as one of the main suture zones of Gondwana. I'm not really sure of that. For me, the Trans-Brasiliano, it will be more like a late stage structure, and it surely follows some of the suture zones, but at places, it just cross-cut through everything. So I'm not sure if really marks a suture zone or is more like cross-cutting through everything it sees in its path, because is a really long lineament, right? It goes like 10,000 kilometers or so if you go from Western Brazil up to Northeastern Africa. So I guess it's just at places is inheriting old suture zones, but at places it's just cutting through everything it sees in its path. Okay, so this is the Transbrasiliano lineament here in Ceará in Brazil. You have got a nice geophysical image here. You can see the drag folds, etc. And what's interesting here, we got a dextral flow in this lineament, so right-hand movement. But then we got those felsic dikes, and those felsic dikes, they are reactivated with sinistral, like left-handed deformation. So this guy here, Wagner Amaral, he dated those dikes, and he dated the Milonites as well. So this is 580 million years, those granulites, and those dikes are 460. So what is he saying is that you got dextral movement, right-hand movement, flow, ductile in the Ediacaran, and then during the Ordovician, you got a reactivation, a sinistral reactivation of those lineaments, okay? Where they go cross-cutting these dikes. So now talking about the granite intrusions, everything that's in red are granite intrusions, Neoproterozoic granite intrusions. So there's a lot of granitic magmatism here. And this is sometimes divided in 5 different stages, depending on the relation with the deformation. So we got the pre-collisional magmatism is around 640, 610, and sometimes those are interpreted as related to a magmatic arc. We got the syncollisional magmas at 610, 590. Then we got the transition to strike slip deformation at 590, 575. Then you got late collisional, late strike slip at 575, 550, and then the undeformed plutons in around 550, 530 million years. Okay, so this comes from a lot of different works. And one of the first to interpret a magmatic arc here is this work by Alan Fetter and others from Gondwana Research 2003, where they interpret this large batholithic system here, the Santa Quitéria system, as representing a diagonal magmatic arc. And the eclogites are just here. So this is a nice distribution where you got the Transbrasiliano lineament, you got eclogites, and then you got the magmatic arc. So that will make sense for a node suture zone here, right? So you got the upper plate, the lower plate, and the eclogites are here in the middle. And this is what they look like, those rocks. They're like tonalites to granodiorites, really like migmatized and rework, etc. And this work by Araújo et al., he interpret both arc magmatism and then reworking, like remelting of those magmas during the syncollisional stage, okay? This came out a couple of years ago. Is an interpretation by Benjamin Blay and others that some of those Ediacaran rocks, plutonic rocks in the middle of the Borborema Province might as well represent ancient magmatic arcs, okay? So those are in red here, cross-cutting the transversal zone. All of those plutons here he interprets as part of magmatic arcs. And I took those pictures in the field, so they're really like diorites, tonalites, granodiorites, and they all got this mafic enclaves here. That's really similar to what we got in the Chilean arc, in other arcs here, Sierra Nevada as well, all dated at around 635 million years, okay? Other picture here, they got magmatic epidotes, lots of mafic enclaves here, okay? Other pictures, so some nice magmatic structures, like snail structures, like these brachiated rocks, etc., where you seem to got like mafic dikes coming on and then just mingling in between the felsic rocks, okay? So really good for those who like to study granites. And all of those rocks, they got a magmatic epidote, okay? So this some kind of petrogenetic interpretation for those epidotes there. And some other nice structures here, like laterites, okay? Mushroom-shaped blobs, injection of diaper-like structures. So for those who like to study igneous petrology and structures in magmatic chambers, those rocks are really nice. I took this picture in the Itaporanga Pluton, and this one is younger, okay? So it's not the arc-like rocks, but we got 584 million years old. So 50 million years later, you got those rocks that are not so similar to the other ones. Now you got really more alkaline rocks with nice feldspar and etc. Okay, so just another picture here of xenolites. So further south, this is new as well, Betania granites. Those are tonalites, diorites, also interpreted as magmatic arc rocks at 630 million years with magmatic epidote and etc. And then this came out in December 31, so just from 2020 to 2021. What we did is study some of the metavolcano-sedimentary rocks that are associated with the plutonic rocks. And we discovered that some of the rocks contain like rhyolites and dacites and other volcanic parts. So this is probably the volcanic counterpart of the plutonic rocks, okay, of the arc. So everything that's in red here are the plutonic rocks that I just showed you, okay, so the tonalites, etc. And then the stars are the volcanic rocks that I collected, okay? And those volcaniclastic rocks, they look like this in the field. So they are whitish rhyolite. When you come closer, they might be porphyritic. They might show some structures of pyroclastic rocks as well. And sometimes you got this corroded gulf, plagioclase and other stuff showing that those are volcanic rocks, volcanoclastic rocks, etc. With all of the geochemistry that shows volcanic arc affiliation, okay? So, and we dated this using shrimp. We got all kind of zircon nuclei. So we got nuclei here and igneous borders as well. So the nuclei we got at 2.4, at 2.0, 2.2, 1.9, 1.8, 1.0, and then the igneous borders, they are all around 620 million years, okay? So this is very similar to rhyolitic provinces that are associated with volcanic arcs, like in New Zealand, where the magma is undersaturated in zirconium. So you cannot dissolve the inherited nucleus. You always have inherited nuclei in the zircon, but that is nice because you can use that to interpret the composition of the basement. So what we have inside those zircons is the entire Borborema province, as I show you. We got the Archean nuclei here, we got the polyproterozoic basement, we got the rifts, the polyproterozoic rifts, and we got the Caridis valleys rocks as well. So you're just remelting the entire Borborema province to form these rhyolites, okay? And we got neodymium work, etc. And what's nice here, the samples here are the volcanic samples, and what's in red and yellow are fields of the plutonic rocks. So they are really similar, the plutonic and the volcanic rocks. So it looks like you got here a full magmatic arc edifice where you got the plutonic roots and the volcanic roof, okay, of the arc system working together. And what we also did in this paper, we got all of the inherited nuclei and we did this histograms. And this is a compilation I did with all of the detrital zircon data we got for the Borborema province. And this kind of mirror each other, right? So it shows that, of course, you got more new Proterozoic stuff in the rocks here, the volcanic rocks, but you got a similar distribution. So it shows that you're just remelting the Borborema basement to form this volcanic rocks, okay? And then I did this this model here, comparing this to the Taupo volcanic zone, back arc zone of the New Zealand, okay? Showing a similar interpretation. And this is in plain view, just showing the coming together West African, Amazonian paleocontinent. And then you got the Goiás-Farusian here, and the closing of the system here, Santa Catarina magmatic arc. But you got another magmatic arc here, which is the stage 1 or Conceição, the rocks I just showed you. Okay, so you got the closure of this oceanic domains here to form this continental arc protons. And then when the Amazon is coming at the end, and when it comes, it will just make everything deform when it collides at the end. So when it collides at the end, it will form this major strike slip system here. So I'm not really sure if that's it's model that would work for the Tuareg shield as well, because it seems to me that some of the shear zones of the Tuareg shield might be a little older, I guess. So maybe these shear zones were already nucleating in this part here. Maybe the West African paleocontinent was already colliding with the Latea and the Saharan metacraton way before we got this here. So probably we're closing in a zipper-like fashion, where you close first the Tuareg shield, and then you go, as you go south, things are getting younger and younger. This could be a kind of model to work with, okay? Because this shear zone here, this shear zones, we got really nice data that shows deformation up to 530 million years. We got plutonic rocks that are included there as well. And here for the Transbrasiliana, we got 580. So that's something that we can discuss and talk about. So just showing a little bit of the syncollisional plutons, like the Rajada suite here. They're like two mica plutons, muscovite, biotite. So this is really going from the calc alkaline rocks. Now we are in the paraluminal suites. That really shows you that you are melting the crust, right? And this is dated to around 610, 590, etc. And those are the post-collisional plutons, where you got this underformed potassium feldspar plutons, alkaline rocks, etc. Okay. Metamorphic zoning, you are always going from the craton to the folds belts. You're increasing the metamorphism, so you go from Grecian phases here. This is staurolite on, this is sillimanite on, and then here you got partial melting. You got anatexis. So it's a classic inverted metamorphism in the NAP systems. The formation in trusses like sheet folds, isoclinal folds, etc. So really, these tight folds here, everything is going from the Borborema Province up to the craton, thrusting to the craton, okay? And at the end, you got this strike slip shear zones that just deform everything. So this is the Pernambuco shear zone showing myelonites here. And you got sillimanite in this shear zone. So the high temperature shear zones, okay? And you can see that clearly in the Google Earth image, drag folds, etc. Okay. So I'm just concluding. I'm just going to show the pictures again of the closer look at the links between Borborema and Northwestern Africa. And what is interesting here, I'm going to take what's basement dominated. Basement dominated is in pink. So I just simplified the whole thing. I just hiding some of the details now, but what's in pink is the basement. And you can see that we've got the Benino-Nigerian shield is really basement dominated, Archean and Paleoproterozoic, and parts of Northwestern Cameroon as well. And then we got here. So here I'll just simplify everything. You know much better than me. I know that some stuff might be wrong here, but we got the basement dominated, like Latia and Eastern Ogar, which might be part of the Sahara Metacraton here. And the stripe here as well, the granulitic stripe. And then we can try to correlate those basement areas from one place to another. It really seems that fringing the province, we got this nice passive margin systems that just go from Riacho do Pontal to Cameroon. And here we got the Dahomeydes, Burma, etc. This doesn't seem to be a problem, but when you go within the provinces, then correlations are more hard. They're difficult to make because everything is really more reworked and then not so easy to correlate, okay? But here's the Santa Quitéria arc, and here we got some interpreted arcs as well in Nigeria. And this is the Iskel, right? You used to be called Silet. Silet is here, right? Yeah, Iskel, Silet, yeah, okay. So in red are the oceanic arcs, like Seruanu, Silet, etc. And in purple are what's interpreted as continental arcs, okay? So we got here the Mayokevi terrain, etc. And what I think is really interesting, this is the Cariris Velhos belt, the 1.0 belt here in blue. And we see no continuation of that in the Benino-Nigerian true. So either this terminates here, maybe beneath the Benue true, or this is hidden somewhere in East Nigeria. Maybe you can find that in the Tuareg Shield as well. So this is something for the future here. And this is from a paper, right? So now we change colors a little bit. So the Dahomeydes belt here, fringing the Benino-Nigerian Shield. This is the Yaoundé belt in Cameroon. And here is the basement-dominated region, right? And in this basement-dominated region, you got some schist belts that might be just vestigial. But you got also this red intrusions here that might be part of arc systems, okay? And then this is, of course, modeled after your maps, after Liégeois and other workers. And I got, when I visited Algeria a couple of years ago, I got hold of the Russian maps and all of the maps that are made. So I think you got nice cartography there. Just trying to interpret this in the same framework, okay? Separating the basement-dominated terrains and then the ones that are dominated by Neoproterozoic volcanics and plutonics, okay? So what's really different here is that you really section it by north-south trending shear zone. So this difficults a little bit the correlations, okay? And this is the paper by Abu Brak, right? At the time, I didn't have the final publication, but what I think can really help in correlations is this kind of geophysical work, right? So this is magnetotelluric work trying to detect some of the probable subduction zones right here, bordering the Iskel shear zone, etc. And this is what Padilha and others have been done in northwestern Brazil, also trying to correlate what are the shear zones that might represent suture zones, like the Transbrasiliano here that shows a really nice conductor that is dipping. So might represent ancient subduction zone here in the Transbrasiliano belt. And this would be nice because you got this conductor, then you got the Transbrasiliano shear, and then you got eclogites, and then you got the magmatic arc. So you will have everything you need for arc system, subduction system, etc. And this is in the central province where they also mapped some of the conductors here that are dipping like subduction zones. So this would be for the other arc system. And this is a more classic work by Oliveira and Medeiros, where they do Bouguer stuff and magnetic stuff as well. It's a nice paper in Precambrian Recherche. This is a magnetic map here of the Borborema Province, where you can trace the major magnetic anomalies they usually coincide with the suture zones, etc. Like here, you got the basalts there are interpreted as ophiolitic remnants. So this is from our paper, once again, just trying to correlate the different basement units and the different rift units, and probably are correlated units in all of the Borborema terrains, and also in Northwestern Africa. So there are a lot of room for interpretations here, but following the major interpretations, we try to put together here the Serenut, Silet Iskel, right? Tilemsi, Ifohas, all of the units that you got in the Tuareg Shield, in the Central African origin, and so on. Okay, so this is a really complex figure that it's better to digest it with time, but surely that might be stuff here that will change, that must change as we go gathering more data. Okay, and those are the interpretations we did where you have a greater San Francisco Congo or Central African block. Maybe the Tuareg Shield was part of it, maybe not. So we don't really know. I just put some interrogations here. And these blocks, they are rifted apart during the Tonian, where you got the mafic, ultramafic intrusions here in Brazil. Maybe you got some Tonian rifting in the Tuareg Shield as well. You have to study for that. And the development of passive margins, okay? And then now you got the arc systems, where you start to close the basins here, okay? And then collision, and you got the final configuration. Okay, so that was it. Thanks for watching, and I hope you have enjoyed this. I want to thank you very much for inviting me for this presentation. I'm on the field right now, as I said, so I couldn't prepare everything up better, but I hope that was enjoyable. And this, I would like to invite you to visit our new project. It's a mobile project where we studied the interaction of mountain belts and the inception of life on Earth. Because when we go to this kind of figure here, in blue, we got the Ediacaran Cambrian basins that developed, foreland basins, right? In response to this orogenic system forming. So we got here a nice mountain belts, né? And you got basins that eroded those mountain belts. In all of those basins, you got Ediacaran Cambrian fossils. So this is the first time that complex life blooms on Earth. And it could be that delivery of nutrients from the mountain belts erosions could boost life development in these basins. So we're studying right now the integrated evolution of those basins and those origins, okay? So, merci beaucoup, and thank you all for watching. Here.
Ok, merci beaucoup Fabricio pour cette présentation qui est très, très intéressante. Et c'est vrai que plus on a des données, plus on se rend compte qu'il faut encore creuser. Alors, sans trop tarder, je céderai la parole au directeur du craag. Et donc, j'ai demandé la réactivation du micro.
Vous pouvez activer votre micro, monsieur le directeur. On vous entend pas.
Ok, monsieur le directeur, je crois que vous avez la parole, pardon. J'avais juste muté le mien. Ok. Vous passez la parole. Je suis arrivé en cours de présentation. Donc, merci de me donner la parole en premier lieu. Bon, je crois que vous êtes tous réellement, je veux dire, partie prenante un peu de toute cette réflexion qui a été faite depuis un certain temps concernant, je veux dire, la compréhension de ce qui se passe un peu de part et d'autre de l'Atlantique. Donc, me donne la parole comme ça, je suis un peu surpris. Je pense que d'autres allaient intervenir avant moi, mais bon, c'est un peu. Anyway, thank you, Mr. Caxito, for this presentation. I hope that you are hearing me. You hear me? Okay, thanks a lot for this brilliant presentation about synthesis of your works in Brazil with all your colleagues and your team, with very nice details about what's going on. What is the geology in the other part of the Atlantic? We already have your presentation here, I think, in craag, if I remember. It was also very nice. I hope that everything is running well for you and your colleagues in Brazil due to the COVID disease. But anyway, the life is going on, and now maybe the situation is more better, and maybe it's time maybe to return more with more power to our work. Anyway, I really appreciate your presentation, not very in detail because I just take the train not in the beginning of your presentation. Anyway, I hear what's about, and what is very interesting to know what's going on in the two sides of the Atlantic, more especially in the African plate, and maybe more especially in Algeria, and maybe to make some investigation to know how is the continuation about all the shear zone that you observe in Brazil, with all your investigation that you made in terms of geology, and how we can do maybe a more global model to see the real analogy in between geology in Brazil and maybe in Algeria. So in the last presentation in craag, we hoped that we can maybe implement maybe a common project with your team and the Algerian team, and maybe to go more in detail with what has been observed maybe in Brazil with a very with a deep detail. I think that we have to do also the same presentation for the Algerian side with all the geological aspect. The synthesis that you have made now, it will be very more useful now to do it for the Algerian side, and then after to ask the major question that it would be very nice to investigate, mainly the Algerian side. You have put some interrogation point. You say that maybe some region has to be more geologically investigated, and I think it would be
very useful to do it, to have a real very first to precise all the relevant question for the two team, and then maybe to know exactly what we have to do in for the Algerian side, and then to maybe to think about what's going on really in terms, and to reconstruct and to do a very good job model about the different phase evolution phase in between voilà, in between the two plates. So for me, as a director, just I said that I would like to thank you for this presentation, and maybe with this reflection in between us, we will have more useful presentation and to ask really a very deep question about this. But if the other colleague have some question about this presentation, this sentence about the geology of Brazil, it would be a first big step to then after to put this interrogation and this question to the Algerian side, and then to extract the more interesting part to construct maybe this joint project. Thank you, Mr. Caxito, and I let the floor to my colleagues to maybe to ask more detailed questions and to know, for example, as a preliminary job has done in terms of geophysics with our colleagues in craag. I would like to thank the team of Mr. Abtut with Deramshi and all the who joined this project, Mr. Bouzid and so on. But we have to join also the aspect here in between geologists and geophysicists to construct a real more deep model to in the interrogation to know what's happened in the Brazilian side. So thank you very much, Mr. Caxito, and I think I let the floor to my colleagues to ask maybe more detailed question about. Thanks. Merci.
Merci, monsieur le directeur.
OK.
Alors, pour celui qui veut poser une question, il y a encore une fois, il y a l'option lever la main. Et comme ça, on va le faire.
So I can just say.
Yeah.
Okay. So merci beaucoup. Thank you very much for your kind words. And I believe we can try to organize something like this, but as a joint
meeting.
A meeting, yeah, a joint small symposium, like some people in Brazil presenting shorter presentations,
yes,
and people from craag also
yes,
presenting shorter presentation.
Mm-hmm.
And what I would really like to do is to get to do field work in a touareg
yes,
field.
yes,
Because in the last time I was there, I was not able to, but I would really love to do that. And then we can select some targets and then go to the field and get some samples.
yes.
And this would be really nice. And of course, if people can come to Brazil, that would be nice as well. Okay. So probably get in touch, maybe with Deranchi or maybe with you other people as well. So we can try to organize a small symposium just as a nice step forward there. Okay.
Yes, thank you.
Is there any possibility, just a question, administrative question, is there any possibility to in the administrative way to have the interaction with your institute or something like that, or if you have some
Yes, I think so. I think we can have some kind of agreement.
An agreement and some
Yes,
exchanges
yes.
and so on and so on.
Yes, we can
it would
try
be
to-
nice.
yes.
It will facilitate really the exchanges and maybe the work between together, and to go more easily on
Yes.
the way of the work together. If there is an MOU agreement, and to do how we can exchange and to have facilitation to have these exchanges, so we can start maybe from the next fall, September,
Yes.
or something like that, to think about the MOU, and then start about how we can do we can start our common project and so on.
Yes. I know that Monsieur Alawa Saad, which work with geomorphology, I know that he did the same kind of agreement with USTHB. So
Yes, okay.
maybe we can try to do the same agreement with the craag as well.
Yes, okay.
So we can
Okay, it
put
would be
that
nice.
in the-
It will facilitate all the things.
Take a look at that, yeah.
Yes, yes.
Great.
Okay.
Yes, thank you, Fabricio, for this great idea. And meanwhile that we are waiting for questions, there are a missing professor in geology. So it's Professor Hadoum. Unfortunately, he's not with us today, but he'd like to ask like 2 small questions concerning the Brazilian orogeny and also the Phanerozoic reactivation. So his first question is about, he said that in the Paleozoic cover which surrounds the Hogar, so several submeridian shear zones have been reactivated and then trigger the raise up of the Precambrian basement in a more than 600-meter shift. Such regions of extensions of the 4°50 shear zone. So he'd like to know, what do you think about that? Or maybe you have like similarities in Brazil, like what I just said.
So can you still see my presentation there?
Yeah,
Or
we can see
okay,
it.
so just go back to the a bit further. This one here, right? Okay. So as I show you here, right, there's some already good evidence for reactivation when you take a look at those dikes, right? The felsic dikes, because as you can see from the ductile mylonites, you got dextrofoliation, and those rocks are dated at 580 million years. But then you got those felsic dikes, and this is brittle deformation. And the brittle deformation is left-handed. So an inversion here. But what's really interesting is that you see this basin here, Parnaíba Basin. This is a really, this is a Paleozoic basin that formed over this part of Borborema. And as you can see, the lineament goes through the basin. So you can see it reactivates Paleozoic strata. It deforms Paleozoic strata. So it must have been active during the basin formation as well. And I believe that it's probably been active even during the Cenozoic, because when you go to the passive margin here, sometimes you can see that this controls some of the structures in the passive margin as well. Okay, that's not shown here, but if you go offshore and you go to petroleum people that works with oil here, you can see that those kind of structures, they continue through the passive margin systems. So I believe this is nucleated here in the diagram, probably nucleated at a suture zone. But then after you nucleate this, you reactivate it a lot of times, okay? And what I think is interesting is that the nucleation is right-handed, and then you reactivate it as left-handed. So probably just adjusting the blocks. And if you think that this is like a transcontinental lineament that goes for 10,000 kilometers or so, those are major continental movements. So you're moving half of Africa in respect to half of South America. If you have this kind of movements going on all over the place, right? If it's the same movement. As I told you before, what's really interesting, the new data we got from the 450 lineament, right? We got stuff from around 640, 630 million years. But here in Brazil, you got stuff that go up to 580. So maybe this is not like synchronous, but you got different movements in Africa and in Brazil. But you definitely got reactivation of this, brittle reactivation. And what I think that's worth mentioning, not all the time this is understood, but you not only got lateral movements, but also vertical movements, okay? Sometimes oblique movements. So you got the juxtaposition of higher grade rocks, higher grade basement with lower grade rocks on both sides, even metasedimentary rocks, etc.
Yes, thank you. It's amazing, you know, because we have in the upper platform in Algeria very big oil deposit, and researchers from the oil companies agree with the fact that submeridian shear zones, especially the 4°51, has played an important role during all the Phanerozoic time period. So in the oil deposit and also in other mineralization. So concerning the mineralization, his second question is, what about mineralization? Are they exploitable, or are they, as in the Hogar, dispersed thanks to successive reactivated events?
Okay, so for the first thing is that here, you see this small basin here, the green basin here. This is a sedimentary basin that's developed over the Transbrasiliano, and it got sedimentary exhalative copper mineralization that seems to be related to this lineament. So you got some kind of hydrothermal system that's working here in this is called Jaibaras, and you got copper zinc mineralization here. So definitely, I think there's some structural control on the mineralization as well. Other than that, what you got here is banded iron formations that widespread. You got pegmatites, etc. But I would think that the most structural controlled are these copper zinc mineralizations here at this point. Okay.
Yeah, that's great. Thank you, Fabricio, for your replies.
Okay, they're here.
Yeah. So I'm waiting with some hands here. So I have just a hand near me. So this is Bukhalfa Zakaria. Also, he's working on the Hogar using the activity.
Nice to meet you, Fabricio.
Okay. Nice to meet you.
No, that's fine. That's fine.
Okay, so I have some small questions if anyone. Okay, so I'd like to ask a question about Pan-African situ zones. I saw in some papers in Brazil, they highlight that using the MT imagery, geophysical imagery method, that there are some, in a way, double sun subduction along the Trans-Brasiliano lineament, for instance. So sometimes this paleosubduction is oriented to the east and sometimes to the west. So I'd like to know what do you think about that?
Okay. So there are some issues with the double subduction, but I think the most prominent is this here. Can you see the mouse cursor there? My cursor.
Yeah.
So you got this is the Santa Quitéria arc. So this is the arc system, and you got the eclogites here at Forquilha, the famous ones. But you also got eclogites at this side. Okay. So you got eclogites in both sides of the arc complex. And as you can see, the thrusts, this is your thrusting towards southeast, and here towards northwards. So some people used to interpret that you got subduction both to outwards and inwards, so double subduction. The way I interpret this, let's see if I can go further to the last ones. Not this one. Yeah, here. So this is what he interprets as double subduction here, Padilla and others. You got this conductor here and this conductor here, and you got eclogites here, and this is the arc system, okay?
Okay.
So just in the middle there, and the way I interpret this, you see, you start the arc system with oceanward subduction, okay? So this is the continent here, Borborema here, and you're subducting towards the ocean. And then at some point, this subducted arc here, it will dock in the continental arc, in continental margin. And when it docks, you invert the subduction. And then the subduction starts to one side, and when it docks, you invert it, and then it goes to the other side, and it becomes a continental arc. And why do I interpret this? Because this is a common situation. You got this in the Sierra Nevada arc as well. You start the subduction towards the ocean there. You got Jurassic arc there, and then it docks to the North American continent. And then when it docks, you force subduction to start in the other side, okay? So I interpret this as a subduction polarity reversal. You start with oceanward, ocean subduction. So this would be oceanic arc, but then it docks to the continental margin, and you got polarity reversal to the other side. So that's my interpretation, but I know that some other interpretations around as well. Okay.
Mm-hmm. All right. Thank you.
Yes, thank you, Fabrizio, for your very important answer. I don't know if we still have some questions or not. Maybe people have some problem with connections to the internet or something like that. But
okay. Will you publish this video in YouTube or something like that?
I don't know. Maybe if you are important, we can make price in YouTube.
Well, if you want to, you can do that. Okay.
Yeah, for sure. We will ask also people if they agree with that. Or,
yeah, for sure. Yeah.
I mean, we will keep in touch and we will see if we will do it or not.
Let's keep in touch about the symposium we talked about, and also about the agreement. Okay.
Yeah. Exactly. Yeah. About other stuff. Okay, so I guess that there's no question here.
Okay.
For those who don't know, you can also ask questions in French, because Fabricio also understands very well the French language and can answer also in French, I guess. Okay, so sans plus tarder, je céderai la parole à Monsieur Abdou. Ok, Monsieur Abdou, vous m'entendez?
On vous entend.
Oui, je vous entends très mal parce que Internet est très instable, donc je vous entends très mal, donc je n'ai pas entendu ce que vous m'avez dit.
Je vous donnerai la parole pour clôturer la présentation.
Oui, donc je remercie Monsieur Fabricio pour cette présentation qui était vraiment très complète, et ça nous a permis un peu de comprendre ce qui se passe entre les deux continents. Donc, je le remercie, et je remercie aussi toi qui as organisé un peu toute cette partie-là. Voilà, très bien.
Ouais, merci.
Merci beaucoup pour l'invitation, pour tout le monde qui a entendu parler pour cette heure-là.
Peut-être Monsieur Bozzi veut dire un mot.
Oui, peut-être que M. Gauzet aussi, peut-être qu'il voudra dire un mot par rapport à tout ça.
Thank you very much for your nice presentation, your nice work, talk. I don't have a question about geology, but perhaps about geophysics.
Okay.
In HOGAR, when we use magnetotellurics, we can show very clearly the shear zones into the crust and into the lithosphere. Is it the same situation in Brazil?
Okay, so I'm not really a specialist on this, but those are the works we got with magnetotelluric. And what the shear zone is appearing here is this portion of it. So I'm not really sure if there are good conductors here that you can show down there. And this is the other work, yeah. So in this work, the shear zones are marked by this shear zone here is marked by a resistor. Okay, yeah, resistor, conductor, resistor. So I'm not really sure it's a good marker or if you got better markers in a Tuareg shield. Okay, but there are always like this conductor, resistor points there. So everywhere that you see an arrow here, the arrows are the main shear zones. Okay, yeah. That's it.
Okay, thank you very much.
Okay.
Ouais. Vas-y, alors.
Super, on va, pardon d'interrompre. On voit bien sur la liste qu'il y a Madame Ouzgan, l'un des spécialistes du regard. On aimerait bien avoir un petit mot de vous, Madame, si c'est possible. Est-ce qu'elle a...
Ça dépend de sa connexion.
Sa connexion, oui.
Oui.
Mais ça nous fera plaisir
Ça nous
d'entendre ça.
Exactement. Vous entendez, Madame?
Je crois qu'elle n'a pas de micro. Ouais. Oui, ça ne marche pas.
Ah, dommage.
Mais dommage, peut-être une prochaine fois. En tout cas, je vous remercie tous pour votre présence aujourd'hui. C'est vrai que les séminaires et les conférences nous a quand même manqué après tant d'années, je crois 2 ans de blocage et tout ça. D'ailleurs, je n'ai même plus la notion de temps, peut-être que c'est qu'une année qui semble à 2 ans.
Pardon, il y a Brahim qui a levé la main. Donc,
oui. Alors, bon, je vais donner la parole à Brahim.
Vas-y, Brahim.
Hi, I'm sorry I don't have a mic today. I'm currently working on mineralization associated with the Pan-African orogeny in the Hogar. Okay, Brian.
In the chat box, you can read his question. You can ask question as well in the chat box.
Okay, I guess that's everyone problem with internet. Okay. Ok, merci Fabricio pour la présentation. C'était un plaisir pour nous. Bon, c'est Elia Brahim Ayat qui vient de poser une question. I just want to know what are the most important mineralizations that you have in Brazil?
Okay, so let me see a map here. A good map. So as we discussed, we got some mineralizations that are in the passive margin systems. We got banded iron formation that might be relation to Neopterozoic glaciation, so sedimentary deposits. But we also have in these pegmatitic rocks here, the granitic rocks, some of those are pegmatitic, and you got tungsten and skarn mineralizations as well, where they cross-cut limestone deposits. And in the Trans-Brasiliano system, you got some hydrothermal fluids going on, and then you got copper and zinc mineralization here. So I believe the main mineralizations will be that, the banded iron formations. You got both Archean banded iron formations and Neoproterozoic banded iron formations. And then you got the skarns and pegmatites and tungsten mineralizations, and then copper zinc mineralization. But also, if I just hit home here, yes, okay. So the people that were looking for, so this work here, Pitarello and others, they were not looking for Archean rocks. They were looking for banded iron formations, okay, in this area here. So this area here, you got important mineralizations, and then they just happened to stumble upon Paleoarchean rocks. So I see your question. We don't have a good definition of porphyry copper mineralizations here, though. For the Neoproterozoic systems, it's more like difficult to have that, not really well described. But when you talk about arc systems and stuff, then surely the companies that go after this kind of stuff and VMS and stuff like that, they are investigating this right now, but not well described as you got in other provinces, okay? So I guess those are mainly, the ones I described are mainly sedimentary systems that has been hydrothermalized, and sedimentary systems that have been hydrothermalized near the Trans-Brasiliano shear zone. But I haven't heard of porphyry copper. We have some IOCG, but IOCG in the Paleoproterozoic, not regarding the Brasiliano, okay? The Pan-African. So not really rich here in the stuff like that. Okay.
Okay, thank you, Ibrahim, for your question, and thank you for
No, I haven't heard but not like a major orogenic gold. We got major orogenic gold in Brazil related to the Brasiliano, to the Pan-African in the Brasilia Fault Belt. This part here, the western, we got major gold mines here that are related to orogenic gold, including in the ARC system. Okay, so if you're looking for orogenic gold deposits, I'll just type it for you. You look for this in the Brasilia Fault Belt, okay? And yeah, this would be where we got most orogenic gold there. So maybe this could help in the targeting of the gold in Borborema and the Tuareg as well. This is the famous Brasiliano, Pan-African, Neoproterozoic gold systems, okay?
Thank you, Ibrahim, for your right questions, and thank you, Fabricio, for the presentation, and also for your replies. So it was an honor for us to invite you today to present, to make a presentation concerning the Borborema Province and possible connections with the African side. It would be nice, as we talked before, it would be nice maybe to collaborate again in terms of papers, or also collaborations between craag and UFMG University. And why not having some PhD students or even master students or something like that? So we will be, it will be an honor for us for doing this. In the meanwhile, you can also come to Algeria. So
Yes, I want to
you're
do the
welcome.
field work there.
Yeah, exactly. We can also
Yes.
come to Brazil if you wish.
Organize the field work.
We
But
miss
not for the
travels.
field trip.
Yes.
Yes. Okay, so thank you again, and hope
Thank you,
that
everybody.
yes,
you.
please stay safe for everyone.
Okay.
Goodbye.
Bye.
Bonne journée tout le monde.
Également.
Également,
Au revoir.
merci.